Obrigado.
Okay, that's working. Right. Okay, so more awards. Nobody's going to go away empty-handed tonight. So this is just a pre-Festivus awards we want to give. It's really to stress how important reviewing is. So we know that there's not much kudos in reviewing. It doesn't really give you a promotion. But it's extremely important that we do it for free. Some people would argue that we have too much reviewing, but I think that's Derek and Maria. But I'd say not. Serious point, of course, amongst all the laughter it's an essential feature of forwarding our scientific endeavour. And sound and constructive, timely reviews are critical. So not the tick box thing, but the way that we do really good reviews is so important. We should never forget that, even though we're kind of doing it for free. So especially the young people among us, the just recently post-grads, then reviewing is so important, even though you might not get a promotion doing it. So it's a way one of the key factors in forwarding our science. So I want to give some awards. Now Sylvie wouldn't, the council would not allow me to give some ones that I wanted. So for example, the most tardy reviewer, you know who you are. And in fact, even worse, the most tardy reviewer set. And there's one senior programme committee member who knows who they are, actually coined a perfect storm of reviewers. EasyChair, you can configure EasyChair to actually sort out reviews for you. And one paper had the perfect storm of tardy reviewers, okay? All three were, I mean, in EasyChair you can see what people are doing because you know when they're last logged on. And the three reviewers, this particular paper, never logged on. So that was going to be another award, but I wasn't allowed to give that one either. The most relaxed reviewer, so that's the one that concentrates on the positive aspects of the paper, ignores completely the negative aspects, and that's still hard. Are you with me? It's a bit of a relaxation joke there. So the positive reviews. Okay, so now we've got the Distinguished Reviewer Awards. The winners, there's two winners. I think you're both here. Oh, that's the tardy one. No, the first Distinguished Reviewer Award goes to Andrew Combs. And the second Distinguished Reviewer Award goes to Patrick Haslam. Well done, very long reviews. Okay, and now it's over to the Festivus.
Thanks. All right, so now the moment we've all been waiting for. Festivus. So Festivus is a fictional holiday that was created on the TV show Seinfeld, or at least that's what Ralph said. And it was held at ICAPS 2005, and then 2007, and 2008. And then we had a really, really long break. Until last year, after a really boring community meeting, I went up to Shlomo and Sylvie and said, can we have a Festivus this year? So they, being the senior guys they are, said, of course, you can do it. So here we are. So just some ground rules. So we're going to have 5 speakers. Each of them is going to speak for 5 minutes. And then we're going to have 5 minutes for grilling by the audience. That's you. And audience participation is not optional, okay? So you are all session chairs now. And then we're going to have a closing discussion of about 10 minutes. All right, so before I introduce our speakers, I want to thank Sylvie for helping gently persuade them to speak. So, here they are. Mark Bobby. Stefan Edelkamp. Sven Koenig. Federico Pecora. And some other guy. And then we're going to have a surprise. So, let Festivus begin. And remember, this is not a spectator sport. I think I have some tomatoes over there, yeah. Just going to go in that.
Okay. There were 2 reasons, actually 3 reasons. I was a little reluctant to do this, and Sylvie did a little arm twisting. The first reason was because when the call for this first came out, Festivus is also described in Wikipedia. It's not just something Rao made up. And the important point is, this is the part of Festivus we're doing. I see no aluminum pole to be dancing around. I'm not going to engage in feats of strength. So this is what you get. Okay, here's the... As I said, I couldn't think of anything particularly controversial or provocative. Okay, but it gets better. Okay. So yeah, they might actually use it, but it's going to be a while yet. Let's see. Bald, old, yeah, I am. Okay. Whoops. Let's go back to that. But that's okay. Okay. This is not nobody ever uses planners, and that's really horrible, and we should all go home. This is not that kind of talk. Okay. That's not where I'm going with this. All right. Some of this was driven by a comment that I actually agree with, but still get under my skin, by somebody who will remain anonymous, except that his name is Derek, which said, this is paraphrased, so he can correct me if I got the sense. I think I got the sense right. And I won't tell you whose papers it's about. Okay? All right. Some other whiny, self-important, self-righteous kind of person wanders around asking this question, or did. This is me, okay? Which is why I can say this. It turns out that's entirely the wrong question. Okay, it's just a dumb way to frame the problem. And this is part of why. Okay, because people say planning. We're doing planning. What the hell is planning? Excuse me. But is it a body of problems? No. Is it a body of techniques? Well, sure. If you include model checking, mathematical programming, constraint logic programming, heuristic search, and probably a few other things that haven't been invented yet, then yeah, it's perfectly well defined. All right, so I only have 5 minutes, so I'm not going to be able to go through this in detail. The reason these are technical field 1 and 2 is because I didn't want to argue more than I already did over what planning actually means. But the point of this is you've got a set of basic theory on the top. This stuff is anywhere between 30 and 50, well, 40 and 90 years old, okay? Typically it was published by mathematicians. We don't do it anymore, or not much. You've got a second row, which is methods, right? These are things that people work on that are how you use this stuff. And for mathematical programming, which is really what this one is, that stuff's fairly well established, although there are new results coming in there. Then you've got a set of tools, which deliberately cross both of these, which people use, which embody the methods which are based on the theory. You get down from that, and now you get into how you start writing problems down using this stuff, all right? And on the side that is not planning, you have flexible planning, forward planning. I'm going to do goal regression. I'm going to do this on a plan graph. Pick one. Then you get down to saying, oh, I wonder what I can use these things for. And typically, and I'll talk purely about this side in this case, they do this by saying things like, yes, I came up with a continuous time solution for refinery scheduling that works for exactly one refinery processing unit and 3 tanks. All right, so toy problems. And that's largely true on the other side for a lot of this stuff, but we'll come back to that. Then you get this thing, which is you have these proofs of concept. People say, I applied this to a real problem. You know, it's real data. It came from somebody. Yes, it did. Once. Okay, they extracted it from their systems. They gave it to you. Your inference method actually worked, and you solved it. Yay. I mean, actually, I mean it. That's a very good thing. But it's not products. Okay? Products mean a whole lot of other stuff, which, and I'll again blame Derek, but he's right, is that there's 90% of this stuff that nobody here, or very few people here, actually care about, that involves UIs and database integration and how you're going to update this. You know, but the products are there, okay? And they're there on, you may notice they're there on both sides, right? There are, in fact, products that have come out of the planning community. And you can, if you feel like you're responsible for one of these, you can decide for yourself whether you qualify as the old, bald, fat, wrinkled, or well-preserved, okay? All right. So now, given that, I kind of understand where things are going, okay? So when somebody says this, I can say that, okay? No, you really don't. You want a problem that you can say came from a pipeline problem, but we've managed to turn it into a Rubik's Cube because that's what Strips rule planners can work with. Okay? Similarly, we want papers about real applications. No, you really don't. You don't want to know all about where I got the information from or all the little engineering details that went into how they work on the problem that have nothing to do with the way that you want to solve it. Okay, I have 1 minute. I'll try and talk faster. Yeah, predictably. No, you don't. Finally, planning systems don't make it into products. Yeah, they do. Okay? And what I think a little demoralized to realize is the first time I heard somebody make this argument was at the first AIPS conference, 1992 in College Park, Maryland. Earl Sacerdote stood up and said, you guys are all whining about how nobody's using your stuff, and that's because you're not willing to take credit for things that happened 10 or 15 years ago because you think they're boring, right? You already did them. It's not new stuff, therefore it's not planning. This is sort of like, you know, artificial intelligence, right? You carve off mathematics, well, or, you know, arithmetic. Well, that's not intelligence because I can get a calculator that does that, right? These days you get a lot more. Symbolic math, yeah, I can get something that does a whole lot of that too. So it's not intelligence, right? It's not planning because, well, we understand how to do that. Yeah, bad idea. Okay, so, and I am about ready to finish up. I have a modest proposal. Slightly more seriously. The mathematical programming side of things, they have multiple conferences. They have multiple academic disciplines that are devoted to those different layers in that table I put up, okay? If you're a chemical engineer, you will spend your entire career somewhere between how you use tools and formulation and occasionally venturing into toy problems and never mind products, okay? I don't think we can manage entire academic disciplines that partition this community, right? We're just not that big. We can't even manage multiple conferences that I can see. But at least, okay, at least, you know, can we agree on something like this? Okay, if somebody's doing Strips rule search spaces and they're talking about how they can do a better job in that, fabulous. But don't ask them when it's going to be used to solve a pipeline scheduling problem or do something in a real logistics problem as opposed to an IPC logistics problem. And similarly, if somebody wants to publish a paper about an application, and I'm talking at this point just about the prototype level, don't ask where the science is or where the new theory is. It's not, and it's not supposed to be. Okay, and if you don't want that kind of paper here, then it's not here, but make the decision consciously. Okay? And finally, and very much along the same lines, decide what you want the IPC to be. Okay, as far as I can tell, real domains are not in the IPC. Okay, the IPC has some things that started out sort of kind of as prototype domains, and people said, well, but how do I compile that into strips? Which, if you're actually interested in solving the problem as opposed to exercising a particular approach, is exactly the wrong question. All right, so either it's about I can solve these problems, or it's about I have this set of theoretical constructs that I want to work on, and I need problems that exhibit those characteristics. Both are valid, but they're not the same thing, and trying to smash them into the same occasion is not working. Okay, as a supporting argument, right? I can name two people, one of whom says the IPC is useless because it's way too theoretical, and it will never address problems they're interested in. It's not me, but and I can name somebody else, or somebody named somebody else for me, who says it's not science because it's way too applied. Right? Same competition. Anyway, that's my rant. Thanks.
The way you said it, it almost sounds like you're saying there is no theory. The way you said it almost sounds like you mean there is no theory in application papers, but I quite strongly disagree. I think to make real new applications, we need new theory.
Yes, you're right. I disagree. Because if I'm going to solve a problem, I'm going to use whatever's available. If somebody says, I can solve this using a very simple depth-first search, right? And I don't need to worry about flexible temporal intervals. I stood up before actually a good-sized fraction of this crowd 7 years ago and said, I'm sorry, I have finally found an application for which classical planning works. Okay, I did. This isn't just a joke, all right? Actually, yeah, you were there. But that's the point, okay? If you're doing this from an engineering standpoint, you start with a problem and you solve it the simplest, stupidest way you can. Now, if what you're saying is that there needs to be a lot of new theory before I can use forward planning over, domain encoded in PDDL 3.0 that's going to work in a refinery scheduling problem, yeah, absolutely. I agree 100% with that. Okay.
What I mean is, I think there's the new theory that you're referring to is not the kind of new theory we need. I think we need really new theory in order to advance the application of what we call planning to the real world. Some things, of course, we can use good old depth-first search to solve some problems. Compile a problem and make it into a CSP and solve it, sure. But I think to push the envelope, we're going to need some new theory. It's inevitable. Otherwise, you'd be saying that planning is dead.
If you claim that, your claim must be right because you're older than me, but if you claim, and fat and big preserved, maybe not fat. If you claim that planning has been used in real products, then at least what we are not doing right is the job of communication within the community, telling them that actually these techniques or the techniques of our precursors have been used in real products, and definitely to outside the community, telling other people outside planning that we have actually been useful, you don't know it, and we can't tell them until we know that we have been useful. And my rant has been that AI community hasn't been very well perceived within planning community hasn't been very well perceived within the AI community. And so I don't know if that makes sense.
You don't get to answer.
So actually, I thought what you were referring by bullet number 2, And if I'll see a paper that solves a problem with the most stupid method possible, I will applaud, first of all. So I think it's great. I mean, I always like simple solutions. Referring to point number one, it's a recurrent pattern. I mean, our festivals can be named festive strips. It always comes down to, wow, why the hell strips? It is not clear that the distance that perceived, at least from outside, between strips and real-world applications really exists. So what about we make a bet? I'll show you, suppose somebody shows you an application with multiple simultaneous users, adversarial domain, partial observability, stochastic event, and in parallel execution of actions in real time. And it is all run by, pick your favorite, FF. And it delivers product that the industry never imagined possible. Will you be giving this, will be changing the slides for the next festivals?
Okay, first, no, I won't be changing the slides. Second, I would love to hear about that application, seriously. Third, I have admitted that I found one domain in which strips rules work pretty well. And my point on the first one was actually a smack at my previous behavior as much as anybody's. Okay? I am not saying that strips rule planners are de facto useless. I'm saying that people that are doing highly theoretical investigations of the structure of those constructs shouldn't be asked that question. It's very different. Okay? All right.
So let me just add that in that application we used Sylvia's planner, and she's neither old nor wrinkled. All right. Thanks, Mark. Thanks.
Hello, good evening everybody. I have a Shakespeare quote, and that's PDB or not PDB, that's a question, or a tribute to blind search planning, and that's what I'm going to do now. So I wrote a H+++++ thing that I really admire heuristics, and then I asked the question, pattern database or not pattern database? And we looked at the merge and shrink and then pattern database, and at the end, as you can see, pattern databases still, as proposed, can do pretty well on all the cost domains. So I was weird that using all these techniques would not supersede what was even in explicit or symbolic. So what's going wrong then? So I chose now a different title for my book. So it's pattern database search now. So I'm only writing about pattern database. And then we looked into the data and looked what happened in there. And then we looked and saw that all the heuristic search planners, fast downward soup, and all your favorite ones in the cost domains are then beaten by blind search. Actually, there's real data, so you don't need any heuristic to get to that performance level. That's bidirectional blind search, so it's a double blind. So I'm actually going to write a book on blind search. That's my rant that Punk's not dead, so pattern databases are not dead, and blind search is also not dead. Thank you very much.
Yeah, Martha, come on.
I can't really criticize that, right? You're talking about the BDD things, right? Symbolic search. It's not like blind search, right? It's more like checking stuff. And I mean, I agree. It's a thing that got us through this community. So I actually think that, you know, I don't want to kind of disclose identities, but there was like reviewing at a popular conference a while ago about a paper on symbolic methods for planning. And I was like one of the people involved in this discussion. There was this comment like, maybe this is a bit of a problematic topic because only one person is working on it, you know? And I really, really very strongly disagree. I mean, it's very important that you're actually pushing this thing, like, for example, Jussi is pushing sub-planning. And, you know, if you beat everyone else with the BDDs, then more power to you. So punk's definitely not that.
So I'll just refer you back to the previous speaker. Yes, use the simplest, dumbest thing that works, but do not ask the person who does something complicated, theoretical, what it's useful for.
Well, there was also one favorite that was on the conference, that was that random search also solves half of the problems that you are looking at. So that's great to see. So probably we need some more benchmarks for that.
Okay. I'll add a serious point to that. I mean, any experiment should have a good baseline, and you know, yours is an excellent baseline.
Pattern database line.
All right. Thanks.
So I'm glad that I'm sort of the middle speaker, because when Sylvie twisted my arm, I had sort of a couple of serious slides lying around. I said, I can volunteer. So I want to follow up on the community meeting, right, where we sort of said, well, we need to reach out more to other communities. And some people said, well, we need to educate others on how our technologies can help them to solve their problems. And Brian, I think, said, well, we need to educate ourselves, you know, how other techniques can help us to solve our problems. And so what I want to add to this is that we're often so boneheaded that we think that other people will come to us, right? And so somehow we need to go out there and sort of tell them what we are doing, and very often we don't do that. And so I want to tell you why I think this. So if you look into our favorite AI book, sort of the Russell and Norvig, then they basically say that AI, right, is all about building these rational agents. And rational agents are those who select an action that is expected to maximize their performance measure. Right? So it's all about optimization in some sense. And of course, planning fits this, right? But I'll say AI in the following instead of planning. And I think we have been pretty good in reaching out to what other communities are actually doing. And the way to see this is to open up this book, look into the table of contents, and so we see things like local search algorithms. Well, they have been studied before us in operations research, for example. We see utility theory. Well, that has been studied before us in decision theory. We see game theory and mechanism design. Well, that has been studied before us in economics. And we see our favorite topic here on sort of probabilistic planning and stochastic dynamic programming, sort of MDPs and POMDPs. And of course, they also have been studied before, in fact, invented, right, in operations research. So in a sense, I think we are doing the right thing here, right? We notice that if what we are really doing is about sort of optimizing some given objective function, that there are lots of other areas that do something like that. And so in a way, it seems to me that we are going down very deep, right, in sort of a very, very narrow area, and we are forgetting that we also want to go broad, okay? Because there are lots of other areas that also sort of thinking about how to make good decisions, even making good decisions by optimizing a given objective function. And I list sort of some of them here: operations research, economics, decision theory, and Brian brought up control theory, and I'm sure there are many others. Now, so it seems, right, I mean, it does make sense somehow to build connections to these other areas. And let me just pick on one of these other disciplines for a second, right? So we sort of artificial intelligence, planning, and operations research. So there's certainly connection there, right? And so there is a community that connects this, sort of the CP AI OR community. We have Chris Beck here somewhere. Where are you? Okay. So there are folks from this community here, and they show that this interface seems to work, but there are many more interfaces, right? Since we're here in planning, right, if we look at probabilistic planning or decision theoretic planning or MDP and omni-based planning, no matter how you exactly frame this, right? Well, I mean, there are people in operations research interested in these areas, but B, they're also thinking about stochastic optimization in a broader framework, different applications, slightly different assumptions there for, different frameworks, but it's all about the same thing, right? It's sort of decision making under uncertainty, right? So in a way, right, I mean, we should be able to interface with them well. So now to my main rant here is sort of over the past year, I had sort of opportunities to talk to more senior folks, I guess, in operations research, right, about this and say, look, let's do something together. And here's the first reaction. The first reaction was, why would we be interested in this? I mean, whenever I would see sort of an AI conference being advertised, I would turn the page. And I said, this is crazy, right? I mean, why would you not be interested in this? And the answer was odd and very unexpected. What they basically told me is they said, look, I studied, remember these are more senior folks, 20 years ago, right? I mean, when I was in graduate school, I took an AI class, and what we did in this AI class, and let me just pick something here, we analyzed to death, time flies like an arrow, right? And how we can look at the sentence and sort of analyze the meaning of it, right? So we don't understand what that has to do with operations research, okay? And therefore we're not interested. And of course, right, I mean, so what has happened is, we have changed focus as a whole community, right? We initially looked more at sort of cognition. Now we look more at sort of engineering intelligence systems. And we have developed sort of great methods. I mean, partially based on what they are doing, right? Like structured dynamic programming, for example, right? So we built on their methods. And so I talked to someone who recently wrote a book in the other community on sort of MDPs and reinforcement learning. Never heard of this, okay? So we need to go out there, I think, and educate people about what we are doing, okay? Now to address all of these three things on my last slide, I like the idea of having joint summer schools and workshops. I think we should task the ICAPS executive committee and IIII council and so on to go out there and make connections to sort of other governing bodies, right? Other societies, do something together. Bring folks together. This way we can learn from them, they can learn from us. I like the idea of invited ICAPS speakers from other communities and the website that we discussed, but I think it doesn't go far enough, okay? And so I don't know exactly what to suggest here, right? So I put down two things, but I'm sure there's something smarter out there. One thing I put down here is sessions on planning at other conferences that might be interested in this. I don't know exactly how to pull this off. Send a bunch of students over there, right? Let them talk about their research. Send out targeted information material to other communities, right? Rent the Informs mailing list, right, from the OR community. Compile dissertation abstracts on probabilistic and decision theoretic planning in the past 3 years, right? And send it to every one of them, right? So that they can at least see what we are currently about, and then they might become more interested in it. Anyway, so that's my opinion, and I'm happy to listen to any comments.
So I think there's not much controversial here. I mean, I agree. Just one question. So ICAPS 14 is trying to, 14. Oh, man. Is trying to collocate with CPIOR. For you, does this go, I mean, just part way, or is this the kind of community we want to look at, or they're just still AI?
So CPIOR is actually sort of a good interface. I mean, there are folks like Michael Trick, for example, right, part of the community who is sort of an OR guy, right, and so people from us, but it's an existing interface, okay? These people already, and I'll take the mic to Chris here in a second, they know each other already, okay? It's great to interface with them nevertheless, right? But I think what we should do is we should open up new channels to other communities who don't care about us. Sylvie wants to get it back.
Do you volunteer to kind of set this up? Yeah. Some more alcohol tasting.
So in fact, I mean, I have done something like this already sort of in the past and sort of built first bridges. And I'm certainly, I don't know whether I'm interested in this context, but I'll certainly push and continue to push. But I promise to get the mic to you.
So I'm not sure what I'm supposed to say, except I agree with Sven. Speaking as a long-standing member of the CPAIOR community, AI is kind of in little letters at the CPAIOR committee. I think we had Maria there giving an invited talk in 2006. Gerard Verfaillie had a paper in the main session this year. But I would very much like to see people from this community submitting papers. And if you're worried about, well, don't send strips planning papers unless you've got a really good story about them. But I would be interested in trying to put together some sort of special track on AI planning for CPAIOR so that you don't get immediately rejected because it's not OR.
Since many of your comments were based on decision making under uncertainty and MDPs and so on, I would just point out that MDPs have a very interesting place within AI and within the general community as well. So within AI, MDP folks are on the fringe in ICAPS, on the fringe in UAI, on the fringe in NIPS, on the fringe in ICML, on the fringe in ICRA. So it's a really interesting sub-community. In fact, we don't really get to talk to each other because the only place where we all come together most often is AAAI. And so it's just a weird place. I don't know what to say about it, but that's where we are. And secondly, outside of the AI community, MDPs have been used in control theory, MDPs have been used in OR, and there is absolutely no communication at this point between these communities. And within AI also there's probabilistic learning and reinforcement learning where there is relatively less communication. So I think there is something to be done about this particular question, and I've been thinking about it, but I completely resonate with what you're saying with respect to OR, but also with respect to the other sub-disciplines that we should reach out to.
So it looks like we have to move on. You already switched the mic off, but let me just say that, I agree, but I think that there's sort of another challenge, right, and that is we should provide a home for these communities, right, rather than letting them sort of disperse, right, and that's something else to think about. Thanks.
Thank you. Okay, so what I wanted to do with you tonight is a little thought experiment. I'd like to start like that. And then let's imagine we're at a party. Now this is a party, but let's imagine we're at a more normal party where, I didn't want to say that, but where we're at a more normal party where our neighbor is likely to turn around and say, so what do you do for a living? So a party with lay people in other terms. So if that happened to me, I'd say, well, you know, I do artificial intelligence, and you know, in the event that I don't bore this person to death, maybe I would actually utter the word planning. I do planning. And at that point, I guess I would have to either give a definition of planning when the person who's really interested asks me, so what's planning? Or I would probably skip that and maybe give an example. And please bear with me here. So the example I'd give is something like, maybe like this. Last week I was in Sao Paulo, and I wanted to go to eat in a churrascaria, and this is the goal of a planning problem. And I have certain knowledge, and I have to perform certain things, and these are the automated procedures that I build for a living in order to get to this churrascaria. And the knowledge that I'd have is something like, probably I'd have a metric map, so something with which I could calculate a route to get there. But probably I wouldn't really look at that too much. I'd maybe abstract away some kind of topological map from this metric map to figure out how to get from one interesting area to the other, one important point to the other. Maybe I'd have some semantics on this map. I'd know that the M stands for subway, and I'd know what a subway looks like, and I'd be able to go in and obviously plan to go in there. I'd know that there exists other transportation modes. I could take a taxi. I would know things about time estimates, how long it takes to go by taxi. It's probably shorter than walking. I'd even be able to infer some things like, well, the lobby guy told me that the churrascaria is east of the McDonald's, and I'm south of the McDonald's, and so therefore I'd infer I have to sort of walk northeast. Or maybe I would infer that, well, as long as I find a steakhouse, I'm in Brazil, so a churrascaria is simply a Brazilian steakhouse. So I'd have this common sense knowledge. So, did I just solve a planning problem? This is maybe what I would say, I think, in all honesty. Well, if that is the case, if I did just solve a planning problem, well, then yes, of course, there was some causal knowledge in there that I reasoned about and inferred upon, but there was obviously a lot of temporal knowledge in there. There was resource knowledge. Notice I probably would have also inferred that not having enough money for a taxi would increase the time it would take me to get to the churrascaria. Right? This is a relatively more complex inference. I would have done spatial inference and so on. So, if this is a planning problem, well, I just talked to you about all these different types of knowledge, and we know very well that in all these sort of little sub-problems, there are some formal results, there are formal methods, there's a lot of previous knowledge, a lot of it coming from this community, of course, that is available to us. Well, then if this is what we want to do, if this is what we want to achieve, if this is the kind of problem we want to solve with what we call planning, well then I think we should keep two things in mind. The first thing is that we have to remember that these inference procedures and solvers and all these other theories exist, and we should use them. And the second thing is that we should start investing in an integration methodologies which really leverages the real power of reasoning in these sub-problems. In particular, there are some examples of this in what this community has done, but also other communities. For instance, putting resource reasoning together with temporal reasoning, right? And it's in a non-trivial way, in the sense that you propagate resources, you propagate temporal constraints, and you search, and while searching, you're using the full power of inference in these two theories. Similar things exist for other types of knowledge and other types of integrations. Now, I'd like to conclude with saying that this is, I think, where the new theory should be, or at least part of this new theory. I think it's relatively important, and I think it's also, it will pay off in the long term if we look at things as we've started to look at. I'm thinking of, for instance, the paper presented here by Derek, things like borrowing ideas from satisfiability modular theories, but also looking at other ideas that have been explored, like meta CSP reasoning or semantic attachments and so on. This is where the theory should be developed, at least part of it. And I'd like to conclude by saying this is not just an academic curiosity. And I think there are plenty of good reasons to do this. Some of the reasons are, I think, the same reasons for which we can apply a subset of what of the tools that we build in real-world applications here, a subset. But not least, there's another very good reason that these kinds of knowledge types are the stuff of robots of the future, in my opinion. Don't take my word for it, but go watch Tony Khan's invited speech tomorrow. Now, this is raising the expectation, isn't it? Where he's going to tell us how we use spatiotemporal reasoning in the context of perception. He's not going to talk about PR2s, that's not the expectation I wanted to raise, but... So, those were my 2 cents. Thank you.
Okay, so I'm just curious, if you're saying that the work that needs to be done is in terms of these theories of integration, are you saying that all the theoretical work in planning is done? Within causal reasoning using something like a strips rule operator. Are you saying all the theoretical work's done?
No, I'm not saying that. I'm not saying that everything is done in strips planning. I'm not even saying that I actually like the blocks world, okay? I'll say it. I love the blocks world. But I also really like making tools that work, and the blocks world is not something that you find in real life unless we saw a paper with a PR2 lifting blocks in the workshop. But no, to answer your question, I don't think research is over, even really in propositional strips planning. But what I'm saying here, I'm focusing on something completely different, and I really want to keep PDDL strips out of this discussion. I really want to... Yes, it was on my slide, but it was there. I mean, I'm not advocating, for instance, PDDL as an integration, as a language within which that you extend ad libitum until you can capture everything in the world. I think in causal reasoning we've done a lot and we should leverage it, but the way to leverage it is together with these other forms of reasoning. This is what we've done in scheduling, for instance.
I have mine.
He brings his own.
So actually, first of all, I agree with everything you said, so I will use this opportunity to kind of... So some students may take out of this and previous presentation wrong conclusion that we should all send agents to other communities and rip them off lots of good ideas, bring them here, so finally we could solve the problem. I try to be polite. Despite the fact being Middle Eastern, I try to be polite. It's hard for me. But actually, when Mark asked what is planning, how I explain to people what is planning, I'll tell you how I explain to people what is planning.
What is?
Well, it's actually very easy, you will not believe it. There are few areas, one of them is CP probably, one of them is classical continuous OR, that have a sole goal of making lazy engineers happy. Okay? No other goal. All we want is engineer coming in the morning, working for 10 minutes and going home. Because alternatives that this engineer, okay, either going home or going to build a new mic. But anyway, the whole idea is not to build 10 systems or 100 systems where you can build one. And that's the idea behind, dancing in linear programming many, many years ago. And that's all.
And someone will understand what planning is by that?
Well, you tell engineer that he will come spend more time with the kids. Believe me, he will like planning even without understanding what the hell it is. Okay? And when that actually happens,
then they'll be interested.
He will sponsor ICAPS for the rest of his life. So that's what we do. We build solvers. And if one community builds solvers for problems type A, and another community builds solvers for problems times B, and then some other community takes this and that, plugs them together, that's wonderful. I mean, but I'm not sure that the sole goal of all of us should be to bring OR, EC, and all other English acronyms in the world together into one room and rip them off. Okay? Easy.
I see your point. The problem, though, is, if I may, do I still have a minute? The thing is, though, I really do mean it when I think that we're going to have to explore a bit more than what we call planning today in order to do something with a robot like that. And I think that's the way also we sell ourselves. I mean, it is a way to sell ourselves to make things work with robots. And in fact, I do also believe that this is really non-trivial, putting this stuff together. It's really not trivial. And I think it's more than using other solvers as black boxes. It's actually about solving subproblems for what they really are. If you have a temporal problem, you solve it as a temporal problem. If you can do resource propagation, you do it. If you have a closed form or a symbolic representation of spatial relations that characterize what the environment around your robot is, you do inference in it because it's the way you're supposed to do it and it's going to be faster. That was my point, more or less.
So actually, when people at a party ask me what I do, I like to say that when the robots take over, it's going to be very, very slightly my fault. So thanks. So now we come to my rant, which is actually related to how we started with the Best Reviewer Award. So I'm going to talk about incentive-compatible reviewing. And as you can see, I've been dealing a bit with e-commerce, so I feel like I won't shame the incentives. So, why do we review papers? So there's the social welfare aspect of the ICAPS community. So we want to ensure that good papers are accepted, we want to ensure that bad papers are rejected, and we want to ensure that ICAPS has a good reputation because that helps us all. So we also get some personal reward from reviewing, right? So we can write that we're on a program committee on our CV, and that looks okay, right? We get early access to some innovative research, and of course we can always say that you forgot to cite me. But this is for comic effect. So this all answers why we agree to review papers. So let's ask another question. Why do we write good reviews? Okay? So a good review is basically one that accepts good papers and rejects bad papers, but not just that. So I'm leaving it abstract on purpose. So why do we write good reviews? So what I'm going to do is use game theory to model basically reviewing a paper. And the game is going to be a very, very oversimplified model of reality. Where have I heard that? And we're going to draw some conclusions from the solution of this oversimplified game and apply them in real life. Because economists do it all the time, so why can't we? So the reviewing game is a very, very simple game. So we've got a single paper to review. It has either the right outcome or the wrong outcome. It doesn't matter if it's accept or reject, okay? We've got 3 players that are the reviewers, and the actions of the player are either sweat and write a good review, or like coast and basically rephrase the abstract and go with the other reviewers. So the outcome is right if 2 or more reviewers actually sweat. And I'm going to be generous here, and I'm going to say that each of the reviewers gets a reward of 2 if the right outcome is achieved, and the cost for actually writing a good review is just 1. So, it looks like something good is going to happen. So let's look at the normal form game. Can you see? Okay. So this is the matrix, and this is where we want to be, right? Everybody sweats and writes good reviews. But these are our equilibria. So you'll notice that there are 3 symmetric equilibria where 2 reviewers sweat and 1 coasts, and there's non-symmetric and 1 symmetric equilibria where everybody coasts. So the desired outcome is not in equilibrium. So let's say that one of the reviewers will coast. We don't know which one. So this is probably not how we want to do things, right? So I have a proposed solution, an abstract proposed solution, okay? So what I'm saying is we should reward good reviewers. So good is underlined. If we reward all reviewers, that's not going to help. So we need to assess the quality of reviews somehow. I have no idea how, right? We can discuss that later. So the Best Reviewer Award is a good start, it really is. That's one. I don't think anyone is going to switch for that. Well, maybe Patrick. So what I'm suggesting is a free beer for good reviewers. So I'm assuming that there are some studies that have shown that people will do more for a free beer than for money to buy two. I know that for a free beer, I have written an awesome paper, or actually tricked DC into thinking I wrote an awesome paper, and I've also gone swimming in Antarctica. All right, thanks. Just updated the slide this afternoon. So, what's that?
Will you swim again for a free beer? Because I'm ready.
If I'm there, if you pay the $4,000 for the cruise and for the beer, sure.
That is not free beer. Not for me.
Right. Anyway.
We still absorb the game.
All right.
How about free beer for every reviewer?
So yeah, so that's not going to work. Because that doesn't incentivize you to write a good review, it just incentivizes you to be on the program committee.
So who reviews the reviews?
SPCs? I don't know, that's what I'm looking for, suggestions.
By the way, giving free beer to everyone may keep us at the same equilibrium, but much more happy.
That's true.
Who reviews the beer?
What's that?
Who reviews the beer?
So actually I said it in ICAPS did something like that. The authors gave feedback to the review. I don't know what happened with that.
If we did have a way to measure good and bad reviews, would it be obvious solution to the whole problem of bad reviews just to be if you get several years of giving bad reviews, you're not allowed to review anymore? I mean, would this be a good thing or a bad thing?
I don't think that's a punishment. All right, so we're going to open the floor.
So just as another comment on getting good reviews from another perspective, the doctoral consortium at CP this year is actually having a shadow program committee. As actually all of these students are going to be writing reviews under the direction of one of the doctoral consortium members as a educational attempt to get across what good reviews are.
I think that's a great idea. Maybe we should try that. All right, so now I guess we'll open the floor for a general discussion about all of the rants or anything else you want to rant about, like, spontaneously. Well, the surprise is after that. Nobody has anything to get off their chest? Okay. Well, if everyone is happy, I guess we can turn to our surprise. So Mark and Lee, in a musical duo, you might want to turn the other way now. Do you need another mic?
No, I don't think so.
Hello.
Hello? I don't think yours is working.
Two.
You could use one of those.
Hello.
So I was walking back from walking to the soccer game in the swimming pool, and I ran into Amanda and Andrew and Christian, and we started talking about music, and they said we really needed a song. So if you want to blame anybody on the content for the song, you can blame them. All right. And then they came up with a subject that it has to be about blocks. So you're there?
So I met Mark 3 years ago, and he said, let's do some music together. And I said, oh, that would be great. And then 2 hours ago, he said, I wrote a song this afternoon. We've got to sing it. So, oh, gosh. I thought you'd give me a little bit more sort of notice.
And unfortunately, the lyrics, I think, are up there. So, you can either look at this or look at the lyrics,
Okay, so I hope this is going to be a yearly thing, right? So,
and because we're in Brazil, we needed to do a Brazilian song. This is a tale of 3 blocks that wanna be stacked on one spot. So they came to ICAPS to be moved. So we can move 3 blocks. What about containers, ships and trucks? Times and resources, they count too. Oh, but what about scheduling? Oh, we need more applications. Please, we don't need more relaxation. Just leave my deletes alone. Just leave my deletes alone. This is a tale of 3 blocks that wanna be stacked on one spot. So they came to ICAPS, and now they've moved. And now they're moved.